We're going to use the theory of linear equations to solve the following differential equation here. So again, that's the theory of linear equations. And to do this, there are some steps that we're going to have to follow here. The first is that we want to assign px and qx values. In doing this, it'll help us better organize what we're doing and put it into our integrating factor and then to the integrating formula, which will give us the linear equation. So to start this off, we're going to have to actually rewrite this. When we do something like this, we typically want our y prime, or dy dx, to be by itself. And to do that for this problem, we're going to have to divide everything by t. So we're going to get dy dx plus y over t is equal to 2. Now our p of x is always going to be associated with our y. So that's going to be this right here, this p of x. And our q of x, which is our other part, is going to be associated with anything that is on the right-hand side. And everything that is not our dy dx or the px is going to be pushed to the right-hand side. So it'll look something like this now. From here, now that we have our px and our qx, we can plug it into our step 1, which is the integrating factor. The integrating factor is going to be I of x is equal to e raised to the integral of px times dx. Now we have an arrow that's pointing px up to our y over t. However, our y over t isn't the entire px. It's just going to be the part that is connected to our y. So if we plug our px into here, it's going to be e raised to the integral of 1 over t, and this will be dt that will change it to. And integrating this is going to give us an e ln of t, which is just going to give us a t. So our integrating factor is simply going to be t. That is not our answer though. We're going to have to keep going because now we need to plug it into the integrating formula. And the integrating formula is given to us as y is equal to 1 over our integrating factor, which is I of x, and then in parentheses we have the integral of our integrating factor times our qx times dx plus c. So we can worry about our ix later. Let's look inside of here at this part specifically. We are going to have the integral of our t, and our q of x is going to just be 2. So since it's a constant, we can actually put it out front, and then we have dt like this. From here, integrating this, we'll have 2t squared over 2. So really, we're just going to have a t in here. So let's write this out. We're going to have 1 over t, and then inside of here, we'll have t squared plus c. So that'll give us a t plus a c over t. And that's pretty much going to be it for our y. Now we just need to plug this in. So we are going to get that our y is equal to a t plus c over t, or you can write it as how we had it right here. So we have it like this or like this. Now either of these is going to work for our y. That's going to solve our equation. It's going to solve our problem. And that's how we would solve the differential equation with linear equations.